Hi everyone, and welcome to lesson 2, where we will get started with doing some of the basics in R and RStudio. So to get started, first open RStudio after you've gotten it installed, and this is the first thing that you will see. You've got the console on the left that interprets and runs all of the R code. On the right, you have a few other panels with various tabs with various information and resources that we'll talk about later in the course. So first I'm going to just increase the font size a bit just so that you can see this a little better. Let's try that. That's a little better. Yeah, we'll just do that just in case you have low resolution or poor internet connection so you can still see what I'm typing. We'll leave it at that for the rest of the course. So as I mentioned in the console, this is what interprets all of the R code. And all of this text here is just what pops up the first time, whenever you open RStudio and it's a clean slate. It just gives you the R version and a bunch of other information. That doesn't matter, you can ignore it. But the console, in the simplest form, R works as a calculator. So we could say 2 plus 3, type it right in, and hit enter or return, and we get our output right here. In this case, our output is 5. Let's do 5 times 7, and we get 35. Now the one before it, just so you know, refers to the index of the value that pops up. So if you had a result that had many different numbers and they wrapped around the screen to the next row, then this number would appear on the next row showing the index of that next value. For now, just ignore that. It really doesn't matter for us at all. What's important is what comes after that. So in this case, it's 35 for 5 times 7. Now, R also uses the order of operations, so you can use parentheses to, 4 times 5 minus, no, let's do times 3 minus 1. And R keeps track of the order of operations. Now, the problem with this is that we have to keep typing this over and over again each time we want R to calculate something. If we do 2 plus 3 again, see, each time you have to go back and rewrite what you wrote before. However, we can fix that problem using scripts. So if we go to File, New File, R Script, now we have a fourth window open in RStudio, and this is our script file. And this works very much like a text editor, so you can say, put in some of the same commands we put in before. Whoops, didn't mean to type that down here. 2 plus 3, 5 times 7. Now you'll notice that when you hit enter, it just starts a new line. It doesn't actually run or output the code, the result down here. To run the code, we select what we want to run, and we can click run, and that will send whatever code we highlighted down here, run it, and this is our output. Or we can just keep our cursor on the line that we want to run and also click run, and it will also send that code down here. Another shortcut that you can use that's a lot simpler and easier than having to click run each time is just Command Enter for Macs or Control Enter for PCs. And you'll notice that when I hit Command Enter, it jumped to the next line. So if you have a bunch of lines of code that you want to run consecutively one after another and see the output of each one, you can just keep Command held down or Control held down and then just keep pressing Enter or Return to get all of those results. And again, they all get thrown down here where we can see the output. Now, before we go on, let's actually open an RScript file that I have already made ready for this lesson. To do that, let's actually open the project that we downloaded, the course files that we downloaded from the course website, and open the project file from those course files. So we'll go to File, Open Project, and then navigate to where you downloaded the course materials and open this file, Essentials of R for Ecologists.rproj. Give it a moment. Great. So now we have up here it should say in the upper right, Essentials of R for Ecologists. This is the project that we've opened, and we'll talk more about what actual RStudio projects are later in the course. But for now, this is just an easy way to organize all the files that we're going to be dealing with and that I'll be showing you through this course. And one of the advantages of projects is that it creates a root directory right where this file is located. So now we have easy access in this little Files tab here to all the different files in the course that we can open just by clicking here. So let's start by opening that folder. We just had lesson 1 previously. It was a PowerPoint file, and now we can open lesson 2 intro notes, which is an R script. When we open that, we can see it right here. Now, what I've done for all of the lessons that I'm going to be going through is I've created these sort of blank templates for each lesson where you can put in your notes as we go along. I'm going to be typing code into each of these different sections of the lesson and talking about different things, and you can use this to follow along, to type in your own code and your own comments. One important thing to remember that will be very useful for doing this is using the hashtag or hash or pound sign to designate comments or commented code in your script. So if we don't do that, let's say we write, here are some notes. And now, if we try to run that, you'll get an error because R thinks that this is actual R code that you're trying to run. So instead, if you just put a little hashtag hash or pound sign before it, just like I did with all of these other section titles, when you run it, it'll still pop up down here, but R won't interpret it as actual code. So you can use that from now on to take notes and enter in code as we go along. All right, so let's move on now. We went over some of the basic math and logic operator. We haven't done logic operators yet. So some of the basic math operators, again, you can just do the basic 2 plus 3, 6 plus 8. You've got 2 times 8. You can raise numbers to powers. So 2 raised to the 3rd is 8. You can divide. Aside from the basic math operators, you can also use some logic operators. So for example, we could say, is 3 less than 3? And we get false. Is 3 equal to 3? And note that I'm using 2 equals signs to designate a logic operator as opposed to trying to assign a value, which I'll talk about in a bit. Does 3 equal 3? It does. You can do is 4 greater than or equal to 4. It is, it's true. And I'm just copying and pasting that. Is 4 greater than 4? It is not. False. And then you can also use the not operator, which is the exclamation point. So you could say, is 2 not equal to 3? True. 2 does not equal 3, thankfully. And finally, we can use some and or operators. So we could say, is 3 greater than 2 and 5 greater than 7? False. And so with an and operator, both of these statements have to be true for this whole thing to be true. But if we use the or operator, which is I think it's called the pipe symbol, and it's usually located above the enter or return key, and it's just this vertical line. It's not a slash, it's just this vertical line. So that's the or operator. So if either of these are true, then that would come out as true, and it does. And so note that in all of these cases, and maybe you noticed up here, I kind of changed the space between the numbers and the operators. R is actually not space sensitive at all. So if you say 4 plus 4, that will give you the exact same result with no error as 4 space 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 plus space 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 4. That will give you the exact same result. It's a little bit of a blessing and a curse. It's a blessing because you won't get errors by accidentally having the wrong number of spaces, but it also means you just have to be a little bit more careful in making sure your code looks nice, and we'll talk a little bit more about good coding practices and making sure your code looks good. But just keep that in mind, that sometimes crunching everything together like this might not look as easy to understand or see as maybe adding appropriate spaces where it seems to make sense. But, that's, for the most part, that's up to you. Okay, let's go on to assigning variables. And this will be one of the most important things that you learn because you'll be using it constantly. Almost every other operation in R involves assigning a value to something. And to do that, you use this arrow operator, a less than sign, and then the dash. And we can name a variable whatever we want. So let's just say we call it variable 1. And you can think of it as variable 1 equals 3, but it's a little bit better to think of it as, since that's an arrow, you can say take the value of 3 and put it into variable 1. The same thing works with the equal sign, but I'll talk about later why it's a good idea to not use the equal sign because you want to save that for a different type of assignment operation. For now, anytime you're assigning a variable or anything, use this arrow operator. So what does variable assigning actually mean? Well, we put that 3 into variable 1. So now if we just run variable 1, if we just run that, out comes the 3. So by running this variable, it outputs whatever its current value is, in this case, 3. And remember that we can also run code by selecting code and then doing Command Enter or Control Enter. So we, instead of just writing this out again and then running the whole line, we could have just reselected that and ran it and would have gotten the 3. But notice that when we run variable 1 with the assigning operator and 3, there's no output. And that's because everything that's going on is behind the scenes. We're telling R to store this value of 3 into variable 1. We're not actually telling R to show us what is in variable 1. We're just assigning something. And so whenever you assign something, you won't actually get an output here. You can name variables whatever you want, as long as they don't begin with numbers. And I believe that underscores and periods are the only non-character or number symbols that you can use for creating variable names, but they also can't start with a number. But otherwise you can name a variable whatever you want. Doesn't matter. Of course, you want variable names to make sense, so this probably is a terrible variable name. And there's certain best practices when naming variables and how to do it, and I'll go over that more over time. But for now, just know that you can create your own variable names and store values in them. Okay, so let's create my variable 1, put a value of 2 in it, my variable 2, put a value of 3 in it, and then sum of vars is my var 1 plus my var 2. So you can store these values, and then the great thing about variables is you can then use them together with any other operator that we've gone over so far to calculate results. So here we have my var 1 is 2, my var 2 is 3, and make sure you remembered if you get an error, it's because you probably didn't run these 2 lines first. And then run that line, and now let's double click to select sum of vars and run that, and we get the result is 5 because my var1 was 2, my var2 was 3, and add them together and you get 5. Great. Okay, pretty straightforward. I promise this will get a little bit more exciting and relevant to data analysis, but just going over the basics to make sure that that is all clear to you. Okay. And again, to sort of, I mentioned this before because I thought it was better to say it at the beginning of the lesson. Commenting is a very important and useful thing to be able to do when you're writing your R scripts and when you're following along in these lessons. Comments allow your code, allow you to put in English, essentially, or any other language that you speak or use frequently that isn't R. You can put that in right into the, put your comments and ideas, thoughts, explanations for what type of coding you're doing, why you're doing it, any notes about what we're doing here. So, for example, we could say variables can contain numbers, letters, and periods or underscores. The other thing I forgot to mention actually is also that variables are case sensitive. So if you did my var1, notice the capital V, and you try to run that, you'll get an error, my var1 not found, because that is actually a separate variable name, because that V is capital. So that's another important thing to keep note. So this is one way to add your notes as we go along. I'll keep mentioning this throughout the course, but it's good to get into a good commenting habit early on. So as you start to analyze your data and write out longer R scripts, it's a really good idea to try to explain every step of the way as you're going. Try to describe why you're doing a particular analysis, why you're running a particular line of code, why it's relevant to what you're doing. Because just like field or lab notes, it's amazing how what seems really obvious and clear to you right now as you're typing the code, even a week or two later, coming back to the code after having done a lot of other work or field work or who knows what, you come back to the code and you're like, gosh, why did I add my var1 and my var2? I can't remember what the point of this was. Well, of course, that's silly, but you know, things get a little more complex in a bit, as you'll see, and it becomes really relevant and important to understand and follow your progress along the way. So I can't stress the importance of commenting enough. Well-commented code makes all the difference. All right, I'll leave that there. I could talk about this forever. But again, in summary, that's it for this basic intro. I quickly talked about sort of the 4 different sections of RStudio. I guess I didn't go into detail, but you know, this is where we can see the files, and then there's other tabs that allow us to see plots and visualize things, and I'll talk about some more of these later. Up here, I didn't mention this. This is the environment, and so as we were saving variables along the way, those variables were appearing here in the environment where we can actually see what the value of each of these variables are. And so the environment stores all of the information that you're working with in an R session, and this is where you can see it. And when we are working with data frames or larger tables of data, we can actually click on the variables here to have a nice little visual display to more easily explore our data. But for now, since these are single values, you can just see what they are right there. And that's about it. So thanks for watching. And in the next lesson, I'm just going to wrap up this intro by showing you how to change 2 useful and important settings in RStudio to make RStudio a more effective and enjoyable user experience. So with that, thank you so much and see you in the next lesson.